Do you want to go faster? Raise your hand. Woo! Okay. Otherwise, if you want to go slower, I believe they are serving the snack. Yeah, you can go there and have a look and enjoy, the food. So here in this talk, I want to tell you the story of, let's say, how we managed to make Git faster. When I say me, it's not me, because there is a lot of people that are working on Git and Gerrit. So for instance, over there you've got Matthias Soden, that is the maintainer, official, let's say maintainer, is the junior of JGit. And then you've got David Pershaus, that is one of the top contributors. Sorry, I hit this one. One of the top contributors of the Gerrit project, and we together worked for years to make sure that Git and JGit are running faster. So just a short note about GerritForge. I don't know how many of you know GerritForge already? Raise your hand. Okay, so you know me, so I don't have to go to this slide. But we have been running and working on Git and JGit and Gerrit for, oh my gosh, I'm getting older, almost 15 years, right? So I'm that old. I saw that some of the people, for instance, Patrick, when you started working on Git?
10 years ago.
10 years ago. I was already, let's say, 5 years already doing this stuff. So I'm glad that, let's say, younger people are joining the project as well. So what about me? So I really like numbers. So Luca is 3,820 commits on Gerrit and JGit. And I've been working on 97 projects on JGit and Gerrit. I'm really impressed, right? So maybe it's time to do 3 more projects. I want 100, right? Let's get there. But yeah, I've been active actually on, this is actually on analytics GitHub.io. We have been running the analytics on Gerrit and JGit for many years because, again, I like numbers. And even if it shows that I just said 2012, it's because before meeting Sean, I was actually starting writing the equivalent on Gerrit that was called Git Enterprise. That's why our blog is still called gitenterprise.me. And then I met with Sean and I say, does it really make sense to do 2 different projects? Let's do one, right? And then we merged all our code base in 2012 and donated to Gerrit, right? So this is my very first meeting with GitHub when it was a small startup, managed by Scott. And there was one of the first developers was called Pef, right? You know it. And I was sitting there, I say, hello, I'm Luca from GerritForge. He would say, I'm Pef, from GitHub. What's GitHub, right? That was the times. And also met the first time with Martin Fick, that is one of the historical contributors also of Gerrit and JGit. And yes, I was younger, right? So this is the road track for today, right? So because I believe that speed is not a one-off, and as Patrick mentions, it's not a you plug ref table, there you go. It's an iterative process, right? We get to the point to go faster because many of the people did a lot of work to go faster. So the work really started back in 2012, right? When there was a hackathon, and those times, this summit was called Get Together, was now here in Amsterdam, was in Mountain View, was organized by Sean, and after the summit, there were also some hackathons. And there was one guy, who will go into details, called Colby, that had the idea of creating a reachability bitmap for Git. That was Git by bitmap. And then we'll go and see how Reftable was invented, I'm sorry, not by Patrick, but by Sean, 2017, so many years ago. I believe Sean from up there is saying, thank you, you made it work. And then went into native Git by Hanwan, and then Patrick took over. And then we'll go into some additional research. We say, okay, we've got so much stuff in Git. Can we, let's say, try to use it in a way that can be leveraged to make everything faster, not just the refs, not just the blobs, not just these, not just that. So we started a couple of years ago with one professor at university in Ontario, Shane McIntosh, the Canadian, and he has been presenting many times at the Gerrit User Summit and Get Together to how to use some intelligent stuff. So we say, why don't you use his intelligence and all the stuff that he's doing for making it faster? And we'll see where we got at the moment in 2025 and what you're planning to do. So just a disclaimer, everything we did was open source, 100%, no if and no but. However, the work that we've done the past 2 years about the research on AI and doing this stuff has been patent, right? So if you want to use it, talk to us, right? We're not going to go to court, but talk to us, we can make a deal, right? And that's the patent number. Yeah, text a snapshot for your lawyer in case you want to use it, right? So let's start with the performance. So who really started the performance idea in Git actually started from Sean. How many of you met with Sean Pierce? Raise your hand. There was an outstanding person, right? I would say really a genius from that point of view, because he really he was really able to go and communicate directly with the code and with the people in the same way. I'm not joking. Sometimes there were some talks and people say, what is it doing? But actually, all the things that he was saying and all the things we were putting in the code, that made just sense, right? And one of the quotes from Sean is, performance is a feature, right? So you cannot really do a new functionality and have lower performance than before, because it means this is broken. If it's not fast, it's broken. Because Git, at the end of the day, whatever we do in development is like a Grand Prix, right? Like a race. Either you win or everyone else win, right? So if you have a feature that runs slower and you roll it out to production, Matthias, what happens if you roll out a new version of Gerrit and then goes 20 or 30% slower? It's going to have a very hard time, right? It's going to go as with the extinguisher and call it a fire brigade. Everything's on fire. Then I would say that Sean was really genius, because was also surrounded by people that had the same ideas and was able, let's say, to really lead them, right? And we got all the people that worked together with Sean, and then we go to Colby. Actually got in touch with Colby. We said, can I use his picture? He said, yes, but please say that it was not just me, right? It was actually Sean that was telling me what to do, and we did it together, right? The bitmap reachability. And it was really interesting, because when he introduced the bitmap, actually we were organizing the hackathon in different teams, and he was in my team together with me. And I'm really sad because he managed to get the bitmap done. And my task was to make a pluggability backend for Gerrit authentication, right? After 2012, bitmap is there everywhere. Where is the Gerrit pluggable authentication? Reverted. So anyway, I don't know, Colby was better than me from that point of view. But he did a fantastic job with bitmap. And even now I would say that bitmap is great, but you really need to read the code very carefully, because was a genius, but was not able to communicate all the good things that bitmap does. And I believe in Git, we are missing many of them, and we'll go to it, right? Then of course, Sean, so introduced, said, what is this backraft and loose raft? This is madness. And he introduced Raftable in 2017, so 8 years ago. And the idea was very simple, right? Why are we reinventing the wheel all the time with Git? So we got basically the pack files are good, then we can repack them. Why don't we do the same with refs? And he started implementation and rolled it out in Google. The reason why he didn't open source that implementation is because Google doesn't use a file system, right? Google uses a different backend. So he said, I could, let's say, open source my ref table, will not make zero sense to you, right? And then, of course, unfortunately, Sean passed in 2018 because of lung cancer. And when he was the manager of the Gerrit project, they say, we should get it done, right? So one of the problems with Raftable was, first, there was not open source for the file system. And the second is that there was no JGit equivalent. Even when he finally implemented in JGit, the problem is that the people say, do I really want to create a repo that only JGit can understand? For instance, Patrick was talking about ecosystem. That's so important, right? Because if you're using a repo that only Git or JGit can read and then Git 2 cannot read, then you cannot use for anything else. So Git button. Do you support Raftable? Yes. No. Okay, sorry. Sorry. They are serving the coffee still. Anyway, you need the ecosystem. Han did a fantastic job in basically writing from scratch the entire open source implementation. So many times when I was talking with Han, they say, okay, you just finished up what Sean did. I say, no, hold on. I didn't use this code. He wrote everything from scratch. And he did a fantastic job in merging it to JGit, right? And what Patrick presented just before would have not been possible without Sean, without Han. Han then, of course, changed company. He didn't continue Raftable, but it's great that we've got a fantastic team with Patrick that took over and made it real and available for Shiny, sorry. Shiny. Okay, and then, of course, we say, so we want to do more. So we put together a team, so that's the name of the people. So the only guy that really knows what happens is Shane. So I will not go into the details of AI because don't ask me. I don't know, right? But he knows, right? And what we did is to put, let's say, a team where there were all the people that actually do the job, they are the ones on the right? And all the people that pretend to know what they're doing, the CEO, and really knows the science behind it, right? But together, let's say we did some work that we want to share with you. Okay, first, so testing. I'm crazy about numbers, I'm crazy about testing. I really want to see tests and numbers before saying we made it or we didn't, right? So first we started with a test case that was not possibly similar to yours, that much bigger, right? You mentioned last night that you guys have got something like 20 million refs in a repo, right? 25 millions. So maybe Matthias, how many refs do you guys have in your repo, largest repo? 2-3 millions. Small one, yeah. But I guess in Google, you got some repos also, they are pretty big, right? So we say, we don't want to give the impression that Reftable is just for the rich. It's only for everyone, right? So we want Reftable for people also that have just only 100,000 refs. We still want to see some performance improvement. Then of course, Git objects are huge. You've got 100,000 refs at least, you've got 1 million objects. And then of course, with people that really read the Google paper about mono repos and thought, oh, that's a good idea, right? So with thousands of people going, pushing and fetching all of them on the same repo. But the point is, if you really want to make some experiments, you need to do over and over again, right? So we need to squeeze something like 1 year of traffic in 1 hour. Can we do that? Yes, we did, right? We use a tool that is called Gatling, and we did some extension to that tool. And that tool is great because we were able to simulate a real team of people and CI/CD jobs they're working together, right? And creating that massive workload compressed in 1 hour. And that's our, let's say, test track, right? Where we use, where the Formula One's going and trying to new engines and new tires. This was the CPU we used, and we actually tested not just with Gerrit, because I believe that Danny did an initial talk on this one. We were just at the early stages, so it was just with Gerrit, and people thought, oh, that must be a Gerrit thing, the thing that just the guys that want to do strange stuff use. Actually, we didn't do just with Gerrit, we did with Gerrit, with GitLab, and we're doing now with GitHub Enterprise. Because if we can make Git faster, why only JGit and Gerrit should be faster? Everyone should go faster. Do you use GitLab? Raise your hand. Do you want to go 100 times faster? Raise your hand. Okay, you can stay. Let's continue. So first, what are the dimensions on the repo that we want to make sure to go faster? Actually, there is a big misunderstanding. People think that a big repo is, oh, I do a d-s on the repo and I see how many gigabytes I've got. That's not big, right? Because if you have, let's say, a repo with 2 refs and 2 terabytes files into the repo, it's not big, because as long as you got enough disk space and memory, that's small, right? The real dimensions that matters are how many objects you got, how many refs, and how many pack files. Because those 3 dimensions in certain operations, they are combined together and they can explode. For instance, Patrick was mentioning about, let's say, some of the operations that were basically repeating the same operation 100,000 times. And especially when you do the upload pack, and CI/CD likes an upload pack. You do your server, if you just do an audit of your server to see how much stuff it's doing, 99.5% is upload pack and 0.5% is everything else, right? So if you can make that faster, then also the machine will have a big relief of CPU you can use for something else. Let's have a look at all the different dimensions, because depending on the dimension, you should use different techniques to make it faster. And that's very important. It's not that you implement Reftable, your repo will go 100 times faster. No, that's just one dimension. But there are many other things you can do. So for instance, if you've got a number of objects, bitmaps, you need to be an expert of bitmaps. You need to read the code wrote by Colby line by line, and I assure you, every single line, it takes at least 5 hours. Because Colby was a genius, and every single line means something, right? The good thing is that he developed with Gerrit and associated with some of those changes that were comments, and luckily, Matthias decided not to migrate everything to a non-Gerrit server, so we can still access the comments made, let's say, 15 years ago. And we can see why some decisions were made, and by working massively on some tuning on the bitmap, you can go so much faster in counting, revlock, search for reuse, and delta chain resolutions. The tuning of some of them, and actually Martin Fix merge a change on JGit was optimizing some of these phases, can have a massive impact. Second dimension is number of refs. So I'm not going to repeat what Patrick said, but everything that Patrick said is great. So follow his footsteps on number of refs. And then you got the pack files. Pack files, you know, there are many ways to improve the navigation. You can use craft pack files to avoid going into loose objects for all the objects you wanted to get rid of it. The preserve pack files, this is a fantastic feature that exists on JGit, but not yet on Git. And that's really important, right? How many of you knows about preserve pack files? Only 2. So how many of you uses any network file system or shared file system? So if you have a shared file system, you go one Git, right, that has some pack files open, and another Git that is doing a prune, what happens? You raise your hand, so you answer. You don't know. I'm not familiar with that part. Yeah, so if you do that, and if you work in a highly scalable system, you don't have just one node, but you go 3, 4, 5, or 15, or a Google, I believe they got something 150 or something, right? Then if you do that, you end into a situation where you have a stale file handle. Then becomes a nightmare, right? So you need to use that functionality as well that in Git does not exist yet, right? So let's go to one by one and to see what were the learnings and what we did to make it faster. So first, let's talk about bitmaps. So we noticed, and that's a real story, that some of our customers, they were taking at least 2.5 hours to create a bitmap. Do you really want to create a bitmap in 2.5 hours? No, because the moment that you need a bitmap, you need it now, not within 2.5 hours. 2.5 hours, you've been fired already by your manager because your Git server is dying, right? And by changing some of the parameters of the bitmap, we managed to go from 2.5 hours to, raise your hand, to what the point that we reached to generate the bitmap? Patrick should know because I told you yesterday.
It was like 2 seconds?
2 seconds. Do you like 2.5 hours spent in, let's say, just crunching your CPU or just giving a lot of your money to AWS, right? In CPU time, or 2 seconds? Raise your hand if you like 2 seconds. Yeah. So those are some of the parameters. I can't go into the details because I've just got 3 minutes to the end of the talk. But if you go into those parameters, documentation in JGit, you can do it as well. 2.5 hours bitmap generation, 2 seconds. Ref tables, I will not go into the details because, of course, let's say Patrick said all of it, but really the text encoding on the packet, a packet rest file was killing the CPU. We did some tuning and measuring the CPU times. The CPU was all the time doing encoding. I said, man, just leave it. Just leave it in the native format. And the most ridiculous part was the SHA-1. It's binary. You transfer into text and then we transfer into binary 3 million times. Doesn't make any sense. We did some tests on ref table on using our Gatling test with Gerrit, and specifically we did it up to version 3.12.2, that is the latest, and we fixed lots of bugs. Before 3.12.2 of Gerrit, you were corrupting basically the repo, or you were corrupting the Gerrit instance because, of course, there were a lot of bugs that we needed to fix. So Matthias Lahn implemented the auto refresh of the ref table that allows the ref table to be cached in memory, so that makes million times faster than go into the file system all the time. Those are the numbers. They are good news. And they are less good news, the ones on the bottom. And that is because ref table is unfortunately slower in managing single refs. So if you have a very big repo and you were used to create refs in milliseconds, maybe a ref table will take 10 or 15 milliseconds. But of course, packet refs is a different thing. So let's go into the results, what we did. So first, the work we've done has been published in a paper. So if you want to take a screenshot, but they will be also possibly published somewhere in the slides, you can go and read the papers. So we published everything we did, and it was presented, and we peer reviewed from all the universities around the globe on the work we've done. They were very critical by saying, you haven't covered GitLab and GitHub. So we did it now, but we submitted the paper at the end of last year, and Shane and Ponch, they presented in Canada, is there. We're going to publish the recording as well. And out of it, of course, we did our product. So our product is the one on the right, right? Do you like to go and fight a race with the car on the left or on the right? Who likes the one on the right, on the left, to try to win a Grand Prix? On the left? Yeah. On the right, maybe it looks better, right? So what is it? So we took all these techniques, all these strategies, and instead of encoding in a kind of complex program or application, we say, man, we are in the age of AI. Why don't we give all these tools, all this knowledge, instead of us, we'll give it to a tool that can learn what to use with what, right? What to use, what works best. Okay, someone wants a coffee, is there? What works best with this repo? What works best with the other repo? And basically taking your existing setup, that could be Git Butler, for instance, or could be GitLab, or could be GitHub Enterprise. Can I make it faster now? So works side by side with your repo. So if you go, for instance, GitLab today, you get GitLab up and running, and that just works with its separate containers. The only thing that needs is your files. And by watching the files in real time, it's trying to understand if your bitmap is not fast enough. Does your bitmap need a little bit of tuning, right? Let me recreate another one. Really tune in a couple of seconds to make your repo so much faster. Or maybe, do I need to do a little bit of reorganization of RefTable? RefTable, for instance, one problem that has, and Patrick mentioned, is that it's doing the reorganization when it wants, right? And that could be an issue, because in some of the cases you were mentioning in Tombstone, if you don't reorganize at that time, then everything else is going to be slower. But maybe this agent can understand when is the right time to do it, right? And do it at that time. Or is your machine struggling with CPU? Maybe even if I could rebuild the bitmap, I don't want to do it because I'm going to kill the machine, right? So this is what it can do today, right? And those are the numbers. So first, those are the numbers with Gerrit, right? And this is similar to the one that Danny mentioned last year. They were already mind-blowing, really. If you can see this curve, I'm just going to explain slightly. So the orange one is basically the best you can get out of Git without GHS, right? Using all the tools, all the knowledge you got, using Git maintenance, that does a fantastic job. And we have just displayed there the cumulative time, right, in running the operations to see how much CPU you're crunching, how many resources you're crunching. And as you can see, as the simulation was going forward, that is exponential. It means when you get to a certain point of the repos, everything that you do is a pain. Everything, right? Why? So you don't want that. You want something more flat, something more regular, something more, let's say, that is following the traffic that you got on your repo. And down you see what the same exactly Gerrit set up without changes, right? With GHS side by side. As you can see, it's really flat, right? Doesn't go up. And the area on the curve, so the worst is 1. It means that everything is exploding at the beginning because that will be completely full. The area under the orange curve is 0.31. If you use GHS, it's 0.03. So it means that if you're running on AWS, I'm sorry, Jeff Bezos, you're gonna earn 90% less money from me, which is good, I believe, because there shouldn't be, let's say, staying there and just crunching your money for doing nothing. I want to use those resources to do more, right? And this is new. We did with GitLab as well, right? So this graph is slightly different from the previous one because we wanted also to show not just, let's say, how good it is, but also how stable are the performance. Those are called ridge lines. So you will see first, we did an experiment of disabling GC with GitLab. Basically, after 5 minutes, GitLab was falling apart. With Gerrit, resisted a lot more because Gerrit is based on JGit and caching, but GitLab is not. So was suffering a lot more than Gerrit. Then we enable, of course, the rule-based system that actually Patrick implemented in Gitly, right? That has a complex system for getting the metrics on the repo and try to do the best maintenance it could. As you can see, it's improving, right? Because the more you go on the right and the more the curve goes on the right, the more you are in the firing zone. You risk to be fired by your manager because Git is falling apart. The more you stay on the left is good, right? Because that's the execution times in 100 milliseconds is definitely better than 100,000 milliseconds, right? But then the more you were sorry, those are seconds, not, let me go top. Yeah, those are the seconds, not milliseconds. So it was improving a lot, but still is able to reduce, let's say, the execution times, but not that much. A certain point it will break. And as you can see with Franco is kind of friendly name, the pet name that we give to our agent, because agents, they look real, they look human. You need to give it a name, AI now. Call it Franco. And the next one, I don't know, will be Lucy. Let's see. Yeah. So just to be politically correct, you use male and female name at the same time. Alternative. As you can see, it's really stable. And it means you could go further, right? We limited this experiment to 5 hours because then the machine was just dying, right, for the others. But with Franco, we could have run, I don't know, for 5 days. And bear in mind, 5 hours is 5 times 1 year traffic compressed, right? Because we wanted to simulate what happens over time. Do you want your GitLab to go so much faster or not? Raise your hand if you'd like to. Yes? Okay. What's next? Because that's not, a racetrack is not just, okay, I won just a race. We want to win, let's say, the World Championship, right? Formula One, not just one race. So first, we had a lot of metrics, and I really like to use the products that I make. And that's why, let's say, GerritHub.io has always been up and running with the latest and greatest of Gerrit and GitLab. And we did the same with GHS. So we are running actually GHS of GerritHub.io. And so far it's great. So the overhead on CPU is very contained. And also the good thing about the agent is that if there is nothing to do, the agent will do nothing, right? It will not waste CPU cycles. How many people do GC when they don't need, right? So that's a good thing. And the second thing, we started with some of our repos. First, they were not corrupted, which is a good start, right? And now we extend it basically to all the repos on GerritHub.io. It means that if you're using GitHub, and maybe you can try experiment, say, the code review of Gerrit by signing up to GerritHub.io, right? There are a few clicks and you get there, and you will be using GHS already. And then your builds will go faster. But then we are working massively on GitHub, right? We started already using GHS with GitHub Enterprise, right? We got already some initial results, but we have some massive testing planned for GitHub Enterprise, especially on the cloud. Because at the end of the day, why on premises, you can say, no problem, I can scale higher, right? I want to buy, I don't know, 5,000 CPU machine, right, on premises with 3 terabytes of RAM, that's fine. But try to do the same on the cloud, on AWS. I believe that maybe you will end up, let's say, be the founder of AWS and, sorry, the investor of AWS because you will spend all your money on them. So you really want to lower your bill and want to go faster with limited resources because AWS is more limited than the power you can have on premises, right? And we already achieved some fantastic results, but we want to go and dig further. And of course, let's say, if we can improve also for any other servers, there is not GitLab, got GitHub, maybe Git Butler, or anyone else, we are more than happy to do that. And then, of course, with all this data, one of the critics on the previous paper was that was just too limited to Gerrit, but needed to include also other Git servers. So then Shane, I believe, will be back. So this year is going to be in Rio de Janeiro. I believe he will like it, right? And we are preparing the second paper, right? So on how to harvest AI and the Git performance now in a much broader scenario. And that's it. Let's have a look. I did 28 minutes, not so much over time. So do you have any questions? Okay. So if you are interested, and if you want to reach out to me, I will be there around. And thank you very much.